let's go over this really quickly. All right, we're going to isolate that variable using inverse operations. And we'll start by saying, sometimes I just like to read it. I say x minus 4, so I'm going to add 4. If I read it out, what it actually says, it helps me realize what the operation is, so I can take the inverse. Negative 3 plus 4, 1. I read this from the variable, x is less than 1. So I go open circle, since there's no equal to line under there, and I'm going to shade less, which is down here. Remember, I can always check to see if I'm right by taking any value from my shaded area, like a negative 3, and replace it in for x, and read it and see if it's true. Negative 3 is less than 1. Yeah, that makes it true. Great. I can also double check by taking something from the unshaded area, like the 3 up there, and it should not be true if I plug that in. So if I plug that in there, 3 is less than 1. Nope, that's not true. So I'm pretty sure I'm on the right track here, since something from my shaded area worked, something from my unshaded area didn't work, so that should mean I'm right. All right, I gotta isolate my variable again. It's on the right side of the inequality this time. I read it x plus 7, so I'm gonna subtract 7. Subtract 7. I got x. I bring down the same inequality symbol. 4 minus 7 is negative 3. That means I'm going to go close circle, because I read from the variable. Remember, x is less than or equal to negative 3. With that equal to, that means I shade in the end point or the circle. And I'm going to go x is less than negative 3, which is this way again. This way again. All right. If you want to, you can check and make sure you're right. Let's go on to the next one. All right. I'm going to read it on the variable side. It says 4 times x, so I'm going to divide by x. Inverse operation to cancel that 4 out and isolate the variable, bring my inequality down, do my math. Negative 12 divided by 4 is going to be negative 3. And I'm going to read it from the variable to graph it. X is less than or equal to negative 3, so I'm going to go to negative 3 and close that circle in and shade left. All right, moving on, I'm going to read the side with the variable, negative 30 times x, so I'm going to divide by negative 30, divide by negative 30. I cancel that out because I use the inverse operation, and I get over here negative 40. And because of this special thing I did, I divided by a negative on both sides. I gotta flip that sign. Zoom. It's gonna turn around and face the other way. Dylan, do your dance move to show everybody. All right. I'm gonna read it from the variable. Start here. X is greater than or equal to negative 40. Whoa, I did some math wrong there in my head. Sorry. 4, negative 4. There we go. X is greater than or equal to negative 4, so I'm going to close that circle. I'm going to shade greater than this time, this way. And we're moving right along. Here we go. Ooh, this one might give you some trouble. You might forget this one, but it's posted on one of my boards. Not for inequalities, but for equations. If there's any fraction in front of a variable, so that means the coefficient, right? That's multiplication. So to get rid of that fraction, we're going to multiply by the reciprocal, because a number times its reciprocal is always 1. So these cancel out, and you get x by itself. Properties of inequality say we have to do it to the other side, though. I can cross cancel. Both of those go to 1. And it looks like I get negative 3 as my result. And I'm going to bring that inequality down. Now I'm going to read it from the inequality. X is less than negative 3, so open circle on negative 3. Less than shades left. This one's a little harder, a little more difficult to check, but you could type all these into your calculator and see if they get you a number that's less than negative 2. Another problem, double fraction problem, but it's similar. If I read it, it says negative 1/3 times x. Well, I could divide by negative 1/3, but dividing by negative 1/3 is the same as multiplying by its reciprocal. So we will multiply by negative 3 over 1, which when you multiply a number times its reciprocal, it always equals 1. So I get 1x on this side, and I'm going to multiply by negative 3 over 1. And that gives me, let's say, ooh, interesting. That's going to give me, that's going to cancel and be 2, cross cancel. And that gives me negative 1/2. Now, did I multiply or divide by a negative? I got my multiplication and my negative on both sides. So I multiplied both sides by a negative. So that means I gotta rotate that sign around. Face it the other way. Zoop. There we go. And now we gotta kind of estimate where our endpoint is because it's negative 1/2. That's going to be right in between 0 and negative 1. And that's going to be a closed circle in there. And then I read it from my variable. X is less than or equal to. So that's less than is this way. And we are cruising. All right. We have x divided by 2. I read that side kind of in my head so I can realize what operation, so I can undo that operation. Multiply by 2, multiply by 2. Cancel that guy. X is greater than or equal to negative 12. I have my variable, read from the variable, x is greater than or equal to negative 12. So we go equal to, shaded in, and then greater than is to the right. Here we go. Oh, this one looks very similar, but uh-oh. There's something a little bit strange here. I'm going to put up maybe an orange little... orange little, this little negative there. It could be tricky. Caution. Maybe star this guy. All right. To get the x by itself, I actually have to multiply here because it's x divided by 3, or negative x divided by 3. But to get rid of that negative 2, when I multiply, I'm going to multiply by a negative 3 because that'll take care of the divide by 3 and it'll take care of that negative out front. So now I'm going to multiply by negative 3 on this side. So that cancels. It also cancels that negative. It's hard to cancel out a negative. There we go. And I isolated my variable. Multiply the negative 3 times the negative 4 and get positive 12. And I'm going to have to rotate that sign. Flip the sign. I'm going to highlight it with yellow because that's what I've been doing so far. And see, multiply by a negative on both sides. Multiply by a negative. That negative's kind of hidden by my little slash there, but it's there. It's right there. Okay, so we have to rotate that symbol, and we read from the variable when we graph this. X is less than or equal to 12, so we're going to go close circle there and shade less over there. I'm pretty happy with how quickly we're going. Let's keep on rolling. All right, now we got the two steppers. Ooh, we got to be careful here. All right, first we get rid of our constant, then we'll get rid of our coefficient, right? That's the constant, the term without the variable. And here is our coefficient, which is part of that term. It's that number out front that's being multiplied by the variable. That's called the coefficient, right? We're going to get rid of the constant first, and it's subtracting 8, so we're going to add 8. Add 8. We bring down our negative 6x, bring down the same inequality. We get negative 6. Now I'll take our second step. If I read it out loud, it's negative 6 times x, so I'm going to divide by negative 6, divide by negative 6, and I get x, and I get 1. And I have to flip that sign because I just divided by a negative on both sides. All right, now it's time to read it to ourselves and graph it. X is greater than or equal to 1. So we have closed circle, and greater than is that way. Moving along, let's keep it going. Go to the side with the variable. It says 2x plus 12. Well, the plus 12 we can cancel out by subtracting 12. We got 2x, bring down the correct sign. We got 8 minus 12. That gets us negative 4. Divide by 2, divide by 2. X, bring down that same sign. No need to flip. I divided by a positive 2. Even though I get a negative answer, that's not what matters. I read from my variable. It says x is less than negative 2. Open circle, and less than, shade to the left. All right. Uh-oh, fraction time. Sorry, guys, don't mean to torture you with these, but I believe in you. I know you can do it. Let's give it a shot. All right. Now, you guys have calculators, so it won't be too bad. I'm not going to use a calculator, so I guess I'm just torturing myself. Anyway, we're going to subtract that 2 over 9. And that's going to cancel on that side, and I'm going to bring my negative 2/3 x down. Now, 1/3 minus 2/9. So 1/3, do a little scratch work, minus 2/9. Well, to do this, I need common denominators. When I subtract or add, they both, 9 and 3 both go into 9, so not too bad. I can multiply the 3 by 3, so I have to multiply that by 3. I get 3/9. Oh, this is a pretty simple one. So 3/9 minus 2/9 gives me 1/9. There we go. All right, now I can bring the regular symbol down because I just subtracted. I didn't multiply or divide by a negative on both sides, so I just keep the same inequality symbol. And now I read it to myself. Ready? Negative 2/3 times x. So when I'm multiplying by a fraction, then I can multiply by its reciprocal. Multiply by its reciprocal to take care of it. All right. So I did just multiply by a negative on both sides. So I need to flip that inequality symbol. Now I'm going to simplify this fraction. So I can cross cancel. That's going to be 1. That's going to be 3. And what do I get? I get 1 on top and 6 on the bottom, and it's a negative times a positive, so that's negative 1/6. Oh, that's going to be tricky. Okay, negative 1/6. Where is that? Well, x is greater than or equal to negative 1/6, so that's going to be really close to 0. Really close to 0. Okay. And then it's x is greater, so we're going to shade this way. All right. If I expanded my number line, okay, and I just had like negative 1 and 0, and I broke that up into sixths, right, I'd have negative 1/6, negative 2/6, negative 3/6, negative 4, right? Negative 5/6, and then negative 1 would be negative 6/6, but it would be like super close to 0. And so I just showed you this little gap right there, but I expanded it so I could show you how close it would be to 0. Anyway, that's what you got. It's kind of going to look like it's at 0 because of the number line so small, but do your best to make it work. All right. We gotta do this last one. We're gonna go to the side with the variable, and we're gonna get rid of that constant term first, the minus 3/8. So add 3/8, add 3/8. We have the negative x over 16 that we're gonna bring down, and the symbol, and we gotta do negative 1/4 plus 3/8. 3/8 is going to stay. I got to change this to 2/8. And negative 2 plus 3 is going to be 1/8. Well, that worked out nicely. 1/8. Now, we have a situation here where we have x divided by 16. So we're going to multiply it by 16, but we're going to make it negative to deal with that negative, this negative right here. Okay, we're going to multiply by negative 16. Uh-oh, I multiplied by another negative. I gotta flip another inequality symbol. All right, so I gotta flip that guy around. These cancel, and it cancels that too. I can't cancel it. There it is. X is isolated, and now we have negative 16 times 1/8. I'm going to put that over 1. I'm going to go get that out of the way. Cross simplify, and I get negative 2. Now I'm going to read it from the variable. X is less than negative 2. Open circle on negative 2. And X is less, so we're going to shade left. All right. Now that was a difficult one. Hopefully you followed along. Watch it again if you're a little confused. Ask questions as well if you're stumped. All right. Good work so far. All right, let's go. Word problems, our favorite. All right. Brielle needs at least $240 for a fancy art easel. She already has $180 saved and saves $5 from each drawing she sells. Write inequality 2. Determine how many drawings she needs to sell. So I like to define a variable first, so that we'll call X. Then I like to look for that inequality statement somewhere in there. Ooh, I think I see it. I'll circle that. At least, all right, at least. So the lowest is 240. So I'm guessing that you guys were able to pick out the correct symbol for that. So greater than right there, greater than or equal to 240. And what's going to calculate, what's going to add up to be her total amount she has, right? The total amount she'll have saved, or she wants to save. Well, she starts with 180. And then she adds on to that $5 every time she sells a drawing. So if she sells 2, it'd be 2 times 5. If she sells 3, it'd be 3 times 5. So we chose X to represent the number of drawings she sells. So there is our inequality. Now we got to solve it. Minus 180, minus 180. Bring down the 5X, bring down the inequality. Get 60, divide by 5, divide by 5. X is greater than or equal to, that's going to give us 12. And it says, let's see, well, it doesn't say to interpret, but what does this mean? It means she must sell 12 or more. 12 or more paintings. All right, let's go on to the next one. Michael saved up a saved up a, I made a typo. Michael saved up $73 to use at Funplex. He only likes to ride the go-karts. Each go-kart ride costs $5.25. He, I guess it's a he, wants to have at least $10 left so he can try to get Mr. Woodworth a cool stuffed animal in the claw machine. Write and solve an inequality to determine how many go-kart tickets he can buy. All right. Well, guys, let's see. How many, right? Solve. Okay, determine how many go-kart rides, go-kart tickets he can buy. So that's our X. And then we know that the inequality symbol is at least $10 left. So he needs to have greater than or equal to $10. All right, he needs to get that gift from Mr. Woodworth. At least. Okay, so where does he start with? We know he goes with $73, and he's only going to ride those go-karts, and so he's going to spend money on go-karts. He's going to go $5.25 each, and the number of times he can ride it, well, that's X. We wrote that as X. So, all right, so now we're ready to solve that. We can subtract the 73, subtract the 73. We've got negative 525x greater than or equal to, that comes to negative 63. And we will then divide by negative 5.25, divide by negative 5.25 x, and we got to flip that because we divided by negative on both sides. So then we rotate it around and we get 12. So what is that? To have enough money for Mr. Woodworth's gift, he's gonna need to do 12 or fewer rides on the go-kart. So X is less than or equal to 12, and X represented the number of go-kart tickets he could buy. So he needs to buy less than or equal to, or no more than 12. Maximum of 12 rides. All right, now those ones were very similar to the ones we've done recently. These ones were from a little bit further ago, and you might want to make them more complicated than they need to be. But let's go. Evan completes problems at a rate of 10 problems a minute on GimKit. He needs to answer at least 120 questions to complete the assignment. Write and solve an inequality to find out how long it will take. All right, well, let's see. We got write and solve an inequality to find out how long it will take Evan to finish the assignment. Sorry for those noises in the background. I guess my son had something caught in his throat. Anyway, so what? And then we're going to look for our inequality statement at least. All right, so that's greater than or equal to 120. And then we're going to say, okay, well, if he gets 10 problems a minute right, and how long will it take? So we're looking for the number of minutes it will take him to get up to 120. So if he does 10 per minute, then that's going to be 10 and times the number of minutes. So we can use M or X. And then it's a simple problem that we just can solve with division. Now, some of you are thinking, well, I would just have divided 120 by 10 anyway. But we're trying to think algebraically, trying to use these inequalities. So that's awesome reasoning. If you thought, well, can't we just divide? Awesome. But we're going to set it up like this first and then show our work. Just to think a little differently, to give ourselves a different way of looking at it. Anyway, that comes to 12. Well, is every answer 12 in this whole test or what? All right, so he has to answer, right? That's what this means. He has to spend, he has to spend more than at least 12 minutes playing GimKit to finish the assignment and get 120 questions. All right. All right, sorry, I'm slowing down. I'm running out of gas. But I can do it. I can fight through it. I can get these last couple done. Joey needs at least 20,000 to earn the target GimKit money for his assignment. He already earned 8,500. Write and solve an inequality to find the amount of money Joey still needs to earn. So we have to find the amount he still needs to earn. So let's call that X. And he wants at least 20,000. So we're going to put 20,000 right there. And at least, so we want to go greater than or equal to that. All right, so we defined our variable. We found our inequality statement, and now we have to figure out, okay, what other information do we have? How does it fit this problem? He already earned 8,500, okay? And then what are we adding on to that? Well, we're adding on the amount he still needs to earn, so we're just going to add on the X, right? The amount he still needs to earn plus what he already has is going to equal the total he's aiming for. So now when we solve it, we're just going to subtract that 8,500. And we're going to get X is greater than or equal to. He needs to earn to get to his target greater than or equal to, that's going to be 11,500 GimKit bucks. All right, so he needs to get at least 11,500. All right. Moving on. Oh, SpongeBob and Squidward both think they sold the most Krabby Patties. The difference in the amount they sold is at most 8. Squidward sold 143, which was lower than what SpongeBob sold. All right. Write and solve an inequality to determine. Okay, so we're wondering about SpongeBob's total. All right. And let's see if we have, next we look for the inequality statement, which is at most 8. So at most means less than or equal to 8. Then it says the difference in the amount they sold. So if we're going to subtract the 2, and we're going to put the one that's bigger, the number that's bigger, Squidward or SpongeBob's total, we're going to put the bigger one first. So let's find the difference. So we're finding the difference. And it said Squidward sold 143, which was lower. So we're going to say 143 goes here. And how much did SpongeBob? He sold, we don't know, X. So the difference between them, right, is no more than 8. Or at most 8. All right, so now we can solve it. 143 plus 143, X is less than or equal to, and if we add those up, that gets us 151. So X represents how many SpongeBob sold. So SpongeBob sold less than or equal to 151, right? Because they can't be more than 8 apart. So if SpongeBob went over 151, then, right, if we compare the 151 to the 143, they can be no more than 8 apart. So 150 would work because that's only 7 apart. 149 would work because that's only 6 apart. Okay, 6 apart, right? But 151 works, but if you think 152, well, that's 9 apart here from SpongeBob and Squidward, so that wouldn't work. So we only want, so SpongeBob could have 151 or fewer. That would be our interpretation. He sold 151 or fewer. Now, really, it's not, 20 wouldn't really be a solution, or 15, because it also can't go below 143, but we won't get that technical. All right, Hudson uses, last one, thankfully, use 15 pencils to create his amazing pencil creations. He wants to make at least 5 pencil creations for the upcoming school supply art festival. Anyway, he needs to write and solve to find out how many pencils he must find on the floor or in between couch cushions to make his creations. All right, so that's what we're looking for, X, and he wants to make at least 5, so we can at least get that part started. At least 5, so that's at least. So greater than or equal to, so check the chart that I gave you and make sure you have the right inequality. And then we are going to solve away. Let's go. Set it up further. Hudson uses 15 pencils to create each of his amazing pencil creations. Okay? So, how many pencils would he need to find to make 5? So, we worked on this. We worked on this pretty hard, and it was hard to get us to recognize, though, what operation was going to be in this problem. But we're going to take a big group of pencils, and then we're going to split them into equal groups of 15 to make each creation. Okay, so our X is the total number he's going to need, and then we're going to split them into groups of 15. All right, so this is one of the division problems. All right, so we're going to now solve this, multiply by 15, and we get, he's going to need to have at least 75 pencils if he wants to make at least 5 creations. All right, so when we interpret it, we'll write a sentence that says Hudson needs to find at least no less than 75 pencils if he wants to make enough creations for the art festival. All right, that wraps it up. I hope that we were able to clarify some things and help you understand those word problems. I know they're difficult, but keep working at them, keep practicing, and you can do it. All right, have a great day.